Yeah, so hi guys. So let's start with the workshop. So like just introduction about myself. Like I'm Shiv, one of the core contributor at Build Guild and also maintainer of Scaffolding. So like Scaffolding is basically a framework built on top of Solidity framework like Hardhat or Foundry. And so basically it has two parts. Like one is Solidity framework part, which consists of Hardhat and Foundry, and front end part, which consists of Next.js, RainbowKit, and WagMe, like which are the latest tool stack of Ethereum. So to get started with Scaffolding, like you could come to scaffoldit.io and you could see the website and you could copy this command and just run it on your terminal. So like once you run it on a terminal, like it should ask you for the name of the app. So let's call it ETHIndia 2024, like 24, and you can choose between Hardhat and Foundry. So let's create Foundry. Like I already did this step, so like we are fast on time. So like I already did this step, and once you do this step, like you would get this kind of a UI. So like I created an app called ETH India 24 demo. I selected Foundry, and after initialization, it should give you the steps. Like next step is to go to CD into ETH India 24 directory and do all these three commands. And you could also go to the docs of Scaffolding to see like what are the steps you need to follow. So like if you go to quick start and installation, we already did this, and then there is, this is how you do the stuff. So it says like initialize the local blockchain in the first terminal. So like let's do that. So for now, like I already created three terminals. So basically when using Scaffolding app, like you will be needing three terminals. Basically three terminals are for one terminal is about running the local blockchain, like the Solidity framework part. Other terminal is to run the front end part, and the third terminal is about running some scripts. So let's follow the steps. So it says like in first terminal run a local network. So let's do that. Yarn chain is the command. So like basically doing yarn chain will start up the local anvil chain which you have, and yarn start. So what does it, the next step says, like it says yarn start, and you could select foundry here, and this will deploy the contracts. Yeah, so it deployed some contract. Like let's see like what scaffold it comes with. Like if let's look at the repo, uh, what it consists of. So like you could open this in your VS Code editor or some kind of editor. Like I am using Vim here. So like scaffold it basically contains these two files like Foundry and Next.js. Like Next.js consists of all the front end part, and Foundry consists of all the Solidity framework part. So like if you see here in the contracts, like we, this is the contract which we deployed, and let's look at the contract. Like this is basically a very simple contract. Like let's go through, go go over it quickly. Yeah, so like this contract basically has some state variables like the owner, the greeting, and then there is the event which we are logging. In the constructor we are setting the owner, and there is a modifier which checks is owner, and then there is this set greeting function which takes in the greeting, like the new greeting, it console logs, and it also increases the counter for that. And if you send some money to the contract, like it sets this premium false to true, and then there is a normal withdraw function. But let's look at like, so we run yarn chain, we did yarn deploy, so yarn deployed the your contract, and now we do yarn start. Yarn start will basically start up your front end. So let's see like what, how does the front end look. So if you go to localhost 3000, like generally Next.js apps start at that port. Yeah, so like let me disconnect. So generally like if you yarn start do, you could see right, like I'm already connected to some kind of a wallet. So this is a burner wallet which comes with scaffolding. Like basically this wallet helps you do fast tinkering on localhost, like, and in scaffolding let's go to debug contracts. So this is a page where you could iterate with your smart contract. So like you could see like the contract functions which we had in the contract, like you could see them on the UI nicely, and you could set some greetings like let's say hello world. This would fail because like I don't have any gas on local network, right? So like we also have the faucet where you could grab funds from the faucet, and this shall increase my balance locally. And now if I set the greeting, like it updates the greeting, and also it updated the total counter. Now if I send some money to the contact, like the set greeting function, you could see the premium flag goes to true. And also like now if I open a new browser, like the new incognito tab, and if I go to localhost 3000, it created a new person. Like this is for local, like these accounts are basically stored on your local storage to do some quick tinkering. So now let's try to edit some contact and see the changes. So for this demo, like I plan to build a very simple app, a kind of a ownable pattern. Like if you guys have used OpenZeppelin, like OpenZeppelin already has this built in, but we build kind of a similar thing for this thing. So like we already are setting the owner in the constructor, right? So now let's try to also have a new function called update owner, which should take in address of the owner, new owner. Let's make it public, and let's try to update the owner to new owner. And like since this is a immutable, like I need to change it now, like since we are allowing to update the owner, so let's update it. And now to again like deploy the contact, you come to the terminal and you run yarn deploy, and hopefully like on the UI, like we would see a new function called update owner, right? And you could test, like you could type in some address and see it changing. Yeah, you see like it updated the owner. But the thing is, like currently if you look at the contract, like anyone can update the owner, like anyone can set the owner, but we need to get this right. So we use require, like msg.sender needs to be the owner, and now I again deploy the contract. So that's the power of this debug contract UI. Is like you could iterate with your contract, like do some editing to the contract, come to the front end, interact, like if every logic works or not. So currently, like the owner is this guy, like 0x a0, and ideally, like I shouldn't be able to set the owner. Let's check it. Like try setting the owner to some address like etg.eth, and it says like not the owner, right? So like now we saw like how we can update the contract and also here update the things. Also like if you look at the stack, like what we do is there is this contract folder and then there is this script folder, where we basically keep the deploy script. So like if you look at this deploy your contract.sol, like this is the script which is deploying the contract, and ideally what we want is initially we want this front end address to be the owner of this contract. So let's change that. Like I could just copy, and now if I oh sorry, and now if I do yarn deploy again, like that below, it should deploy a new contract, and now this front end address should be the initial owner, and now I could update the owner. I mean that's cool. Like now we have a basic app. Like I mean like we don't want to ship this UI to the end user. So like let's create a production UI where like a user could interact. So like I think this is kind of an admin app. So like let's create an admin view for the page. So in scaffolding, like so now we go to the front end part of the scaffolding. Like we already done the contract. Now you start writing some UI for the contract. So, since scaffolding is just basically a Next.js app, like you could just follow the Next.js. So like to create an admin page, like you create a folder admin slash page.tsx, and let me just copy the things here to page.tsx. Like let's call this admin, and let's see if we have the slash admin route. Yeah, cool. Like we already have this admin route, and like to add it to the header, like you could search here like header and add that link here. Let's just copy this and keep this as admin. let's see. Yeah, so like now we could easily navigate to the app. So like now let's create an UI for the contract which we developed. No, so like in Scaffoldit, like so Scaffoldit has a bunch of utilities to quickly build this front end things. So for reading through a contract, like if you need to read a state from the contract, like we have these hooks called use scaffold read contract hook, use scaffold write contract hook to basically write to a contract, and this follows the very similar interface to WAGME. Let's try to maybe read the owner of the contract. So let me just clear this all stuff. And by the way, like Scaffoldit uses Daisy UI. If you guys heard about it, like Daisy UI is a component library for Tailwind. So like it uses Daisy UI as a component library, and you could search some components here. Like let's use the card component here. Let's just copy this. We don't need image from here. Let's see how does it look on front end. Yeah, so like now let's try to display the current owner of the contract, right? So let's change the this to admin, and let's try to get some state, like let's try to read some state from the contract. To read some state, like you could use scaffold hooks called use scaffold contract read, use read scaffold contract hook. And the thing is now these hooks has nice auto completions. Like if I show you, like if you write the contract name, the your editor will nicely give you the auto completions for the TypeScript. Like it's saying your contract, and then here you could mention the function name. Let's call now, like since it's a read hook, like it only gives me the read variables. So like let's read owner, let's call it data current owner, and let's try to display that here in this p tag. It's called cur owner. Yeah, you see, like now we are displaying, like we are reading straight from the contract and displaying it on the front end. But like I mean, this is bad. Like we are just displaying the raw string. Let's try to display a nice address component. So like for this, like we also have address component in Scaffoldit, which is able to nicely display the address component to the UI. So you see, and now like if I update the owner to some address which has ENS to it. Oh shit. Yeah. Let's update the owner to shivbunde.eth, and like if you go to the admin page, like it also nicely, the component nicely resolves the ENS, the name, and also the ENS profile. So like let's for now call this as I'm short on time. Let's try to and, and let's call this owner. And now now like let's suppose like we need to give admin a UI to update the owner. Like how do we do that? So like let's so to give the admin an UI to update the owner, we'll be needing an input where admin writes the address of the new owner. So like let's have a state for that. Let's call it const new owner, and again like we need some input, right? So for this, like we could use the same thing. Let's call it update owner. And again like scaffold it again has a nice utility for the address input. So like we use that, and we give on change. Let's see on the UI like what we got. Oh, I think use state is not imported, so let's import it from React. Yeah, so now we also have the nice utility to update the owner, where the admin could input like who will be the next owner. So like you could add here, and this address input component will update nicely, like resolve the ENS and show it on the UI. So now what we do is like when clicking this button, like ideally uh, this should be called change owner. And now let's try to like, ideally what we want is clicking this button should update the owner. So like now we need to write it to the contact, right? So like we use again the hook from the scaffolding, use scaffold write contact hook. For here you need to give the contact name, and if you guys have used wagme, like it's pretty similar to wagme, so let's call it, yeah, let's call it write contact. Then we create a handler, const handle change owner async. Let's wrap it in try catch. And now we use that function to write to a contact. It's called write contact async. And now since we already have the contact state, now like it should give you the auto completion, like what all the read functions we have. So like we need to write to update owner, and like it also gives you an error like, hey, this function accepts an arc, so like you need to pass some arcs. So to the arcs, like we pass the new owner as the state. And now let's attach this handler to the button. On click, we call that handle change owner, right? So let's try to set a new update owner. Yeah, I mean like I already changed the owner, so like it's saying like not the owner. So like I mean if we deploy the contact again, now ideally like my connected address should be the owner, and now we should update, able to update it uh, on the UI. Like now we change the owner to etg.it, and hopefully this should update the owner. You see, like now we already have the UI where people could interact with nice components. Now let's try to deploy this app. I don't know like if we'll be able to do this, but let's try to deploy it to some testnet. Now like we already tested app, we already have the UI. Now we need to deploy the things. And by the way, like all these things are available on scaffolded docs. Like you could go through all these things, like where I'm saying like components, like you could see here all the components, like how to ship your app, deploying your smart contracts. So let's try to deploy it. So like for Foundry version, like we are using Keystore, like Foundry Keystore. So to do that, like you need to generate an account. So this will basically generate some Foundry Keystore account, and you see like it says like Keystore was saved, and it created this random address called 0x9b, and it says like please update your env file with Keystore account scaffold is custom. So let's do that. So if you go to Foundry folder and .env, like here we change it to scaffold is custom. So here you could change it to scaffold is custom, or you could give your own keystore account. So like I already have my keystore account, so like I would use that. So I have called it personal, so I would use that. And you could run this yarn account. So like basically yarn account is the command which shows you the balance of your account, like which is gonna be deploying it to the mainnet. So like let's try to deploy this to Optimism Sepolia. To deploy this, like you run, oh, let me do this. Yeah, like here to deploy this to Sepolia, like you need to run yarn deploy dash dash network Optimism Sepolia. Oh, like let's update the uh, deployer account so that we are the owner of the contract. Like let's go to deploy your contract, and let me just put my MetaMask address here as the owner. I mean, we are short on time. Let's try to deploy this. If I do yarn deploy dash dash network Optimism Sepolia, now this should ask for my keystore password, and once it's done, like it would deploy it to Optimism Sepolia. And now the front end, let's look at the front end. So currently, like if you click the address component, like it goes to the, oh, I think I closed my front end. Yeah, this, so the contract is already deployed, but like currently this the front end was configured on localhost, like it was reading the contract from the localhost. But if you want to point it to now, since we have already deployed it to Optimism Sepolia, like you could go to scaffold config, and here you change the thing to Optimism Sepolia, and let's change the pooling interval to 5000 seconds. And now you, if you refresh the app, like this should leave on Optimism. Let me try it. And it says like owner is my wallet. Let's try to switch to Rainbow, and it says like here wrong network, now I switch to Optimism Sepolia, and I update the owner to etg.eth. If I do that, it should tell me to sign the transaction. And yeah, hopefully like once this is confirmed, like now like the whole thing is pointed to Optimism. So if you click this link, it will take you to the Optimism Sepolia block explorer. If you click this address, it will take you to the Optimism Sepolia block explorer. So by just changing this config, like you are already talking with the contract which are deployed on Optimism. Like if you change it to Foundry, it will talk with the localhost thing. And yeah, I mean, now if you need to ship this to, if you need to ship this app to Vercel, like you could run this command called yarn vercel dash dash yolo prod. So yeah, like this should ask me something like set up your project. Let's have it under my section. Like I need to create a new project. Let's call it ETHIndia demo. Yeah, I mean this takes some time to deploy, but yeah, until like we could see like you guys, not only you guys could also start with some extensions. Like we also have some extension, like if you want to get quickly started with some of the extension, like you have subgraph bounty. So like scaffolding also have this extension, so you already have subgraph built into it. Like we have ERC20 on-chain kit extension. Like if you are planning to also hack with other sponsors, like you could use these extensions as the start. And yeah, I think this will take time to deploy, but yeah, like once this is deployed, like you guys could try it out. And yeah, like make sure you check the docs. Like docs has everything. uh, and we also have the Telegram channel for the ETHIndia folks, so like you could also text me there for any support. Yeah, let's see. So it's still building, and until like maybe I'll do a quick shield of build guild. So basically, if you guys are learning about Ethereum, like you guys should go through the buildguild.com. Like we have a nice curriculum to teach you about Ethereum, like the basics of Ethereum. Like you could follow all the challenges and learn all the stuff about Ethereum, like all the gotchas. And also you build some nice apps like Dice Game Decks, SVG NFT, and then you join Build Guild. Let's see if our app is deployed. Yeah, already. Yeah, yeah, cool, cool. So yeah, I think the app is also like if you go to ETHIndia dash demo dash Vercel dot app, like you could already try this app out. ETHIndia dot demo dot Vercel dot app, like you could already see the UI and interact with the contract or even the admin. Like I mean you guys wouldn't be able to set the admin since the admin is atg.it, but yeah, like yeah, you scaffold it. And we also have the bounties. If you try to build on scaffold it, like you should apply for the build guild bounty and you might win something.
Guys hear me okay? Ah, amazing. Great. Hey, my name is Andrew Joseph. This is Anup. We are from Eigenlayer, the creators. We work at Eigenlabs, the creators of Eigenlayer. And we're going to talk about AVSs. What are AVSs? AVSs are actively validated services.
This lights.
Okay. I, I think it's fine. They can hear us. Like, can you raise your hands if you can hear us? Yeah, they can hear us. Yeah, thank you. Why we'll talk about why build an AVS, an overview of Eigenlayer, and Anu will give you a demo of a Hello World project. This is this is available on GitHub, so you can like use it as a starter project. We are sponsoring bounties today. Uh, One is an AI bounty, so you can create like an AI agent on Eigenlayer, and one is a novel use case of Eigenlayer. So uh, we'll give you some ideas towards the end of this presentation on what to build and all that. So why build an AVS, right? So what is an actively validated service? Uh, so imagine Ethereum, right? Like we have so many services built on Ethereum, like bridges, for example, oracles, and we need all this to like run DeFi or lending markets, right? Like all of these applications we built on Ethereum requires all these services like oracles, bridges, whatnot, right? These are services that are external to Ethereum, and these require some sort of security, so we can use them and be confident that our funds are safe and secure, right? And how do you secure them, right? Like we secure it with like money, like capital backing these services. Honestly, that is called economic security, and Eigenlayer is a service that allows you to easily bootstrap economic security without spinning up your own network and asking the stakers to like deposit funds or like paying out operators with inflation of your own project's tokens and things like that. So when you're launching a new Web3 project that requires bootstrapping any sort of like a network, like a bridge, for example, or an oracle, or a DA layer, intents, all of that can easily be solved by Eigenlayer because Eigenlayer allows you to easily bootstrap economic security. So an easy way to think about economic security is that imagine a bridge that wants to bridge like $1 million back and forth between two different blockchains, right? If the bridge is not secured by more than $1 million, it always makes sense to attack the bridge and get that money, right? So crypto economic security is the cost of attack should always be higher than the profits you gain from attacking the system, right? So that is what we are talking about when we say economic security. And what is a shared security, right? So if every network, like every oracle or every bridge, were to bootstrap their own economic security, you would split up the capital, and it will be very inefficient, right? Like we have like multiple layer ones today. Imagine they all shared like security, then it would be like a better system. But when you split up capital, it becomes capital inefficient, and the cost of attack goes down. So pooling capital together increases the cost of attack. So that is what we mean by shared security. So different services share a pool of capital, and that increases the cost of attack, and it is capital efficient. So let's talk about uh, how shared security works on Eigenlayer. We have restakers, so users like you and me can deposit funds on Eigenlayer, and we delegate that capital to operators. So operators are like service providers like Coinbase, Figment, like anyone who could run a validator could be an operator. It is all permissionless, right? So we have operators, and actively validated services are the products you will build on EigenLayer. So things like oracles, bridges, AI agents, all of them are AVSs. And we package this, and a consumer would be using your services like the agents, the bridges, the oracles to do what they want to do, right? And so how does this flow, right? So risk-takers delegate their capital to operators, and operators run AVSs. So that is how it works on EigenLayer. And now Anup will give you an overview of uh, a very basic AVS. And yeah, I'll hand it over to him.
Hi everyone, I'm Anup. I'll go over a very basic AVS to help understand how the system interacts and how you would build the AVS that you want to build. And I'll give you links for more complex AVSs that are live today as well. So let's take a very simple Hello World example, which is you, let's say the consumer, have a need to say hello on, the contracts and secured by EigenLayer using an AVS as well. So what the flow here that you're seeing is you would send a request on chain to say that, hey, I want to say hello to the world. And a transaction is sent on chain and an event is emitted. The operators that was described earlier will look at these events and say, oh, I actually have work to do. So it will download this event from using your RPC and other things, and it will have predetermined code as part of the design of the AVS and say what needs to be done. In this specific case, it's very simple. It says, oh, I need to say hello world and sign it and send it over. So that is step 3 and 4 that you're seeing. After the event is received from step 2, the message hello world is seen, signed, and the data is sent on chain. And step 5, where you see the amount of stake and what is needed, is calculated. And these options are actually up to the AVS to define how you would want to calculate and hold all these things together. So let's go through a simple demo here, and I'll go through the code as well. Okay, so the screen up top that you're seeing is going to be the AVS code, and as you see, it starts an anvil chain. I will share the link for this code that works, and you guys can fork it and build very easily on top of it. The next 2 things, what we'll do is deploy the EigenLayer contracts and deploy your AVS contract. So with this, what you're doing is you deploy all the things needed for EigenLayer to work, and you deploy your hook, your AVS hook. We call it a strategy manager, service manager, sorry. And we use that to talk through EigenLayer and have the mechanics work with it. So on the left side, both the EigenLayer contracts and AVS contracts have been deployed. So now we will start an operator. And as you see, the operator is written, you have option to write the operator code in any language you wish to use, as long as it conforms to the spec that we have, and then it serves your use case as well. So here I'm using the Rust operator to run a single operator for the AVS. And on the left side, I'm saying, run some hello username example. So in a few seconds, it's building. So here, as you see, it sent a task saying that Hungry Dog 500 is what I want the operator to respond. And that is the task that is sent on chain. And you can see through Anvil that you have tasks registered and you have the response from the operator as well that you see here on the bottom left screen. The operator received a new task, hello hungry dog, and it responded and with the transaction hash. So we run this for couple of while, and this can be long running services, and it depends on you and how you want to define your AVS. So I'll go through the code on what this looks like. So as you probably remember, we have a create task, something that you consumer would actually need to create a task to interact with the system. And you have the respond task, which is how you would actually respond to the task you received. And this is the contract that you're seeing. And if you see in the respond to task, you have the reference checks on am I supposed to respond to this task? Does it match my requirements? And is this actually something that I care about? And after all those checks, you see the message hash, which is hello and the task name that was sent. It is signed and it is sent on chain so that there is a record of what the operator has done. And with that information, in case any operator chooses or with or without intent behaves maliciously, we are able to have cryptographic proof of its behavior, and we are able to enforce slashing as well. So this is the off-chain code. Here you have a few functions, which is the register operator. The first part is you spun up the AVS code, and if you're running an operator, but you cannot just randomly start responding to tasks. Eigenlayer enforces some amount of restrictions. So one of this is you need to register, and there is keys and other things required, which we have helper scripts to help you build an AVS faster. So the first part is you would register as an operator, because what would happen is after you register and when you respond to a task, you will be able to see, Eigenlayer will be able to see that, yes, this operator is actually active in the system and is actually allowed to respond to a task. And sign and respond task that you see on the right side is actually the off-chain code responding to the quote-unquote task name here, which is hello world. And the bottom screen is a monitoring script, which is a piece of code, which essentially says every time I receive a new event, I need to respond to this task. Because if you choose not to, depending on how the AVS is configured, you might be susceptible to slashing and other things. So the next steps here is as Andrew mentioned, we have two big bounties. One for the most novel use case of Eigenlayer, and one is some of the best AI apps that all of you would help build on Eigenlayer as well. So love to see your ideas on these. These are the links that we use to show the demo, and you have way more information on this page, which I will go through as well. So if you want, you can scan the codes and you'll be able to get working and forkable code to help kickstart building AVSs. If you want help or understanding of any specific areas, you can reach out to us. And Build on Eigen is our Twitter account where we tweet out very interesting projects as well. So this is the documentation that will help benefit everyone quite a lot, which is how this AVS off-chain, on-chain, both the systems interact, what contract an AVS would need to write to work with Eigenlayer, and how your AVS would need to work with its own contracts is up to you. So it helps differentiate what things we would need to work, what things an AVS would need to work with Eigenlayer, and apart from that, whatever you would need for your AVS to work. And also you have deployment scripts, which will help kickstart your project for AVS. and you have the off-chain index.ts code, which I went over in more detail and explaining on how this works. And you have a task generator as well, which helps you to, simulate traffic and show how your system is actually working. And we have local DevNet deployment steps as well. And if there are any more questions, happy to take. But yeah, that's pretty much it. Thank you.
Hey guys, so how many of you have heard about Polkadot before? Can anyone raise your hands? Okay, wow. So can you really deploy smart contracts on Polkadot first of all? Does anybody know the answer? Okay, so what do you mean? Do you mean parachains, right? Or are you speaking about West End? So today we are gonna deploy smart contracts on Polkadot, but actually it's gonna be one of the parachains called POP network, which provides a seamless way to deploy smart contracts on Polkadot. So Polkadot is like the next generation technology to build your applications. So it also provides shared security to its parachains and economic security as well. And we won't the topic won't be much about Polkadot, but you know how you can first deploy your contracts here. So some general idea we need to think about is uh, what is Polkadot actually? Polkadot is like the relay chain which secures different parachains, correct? And what is Paseo? Paseo is like a relay chain testnet, and there are also some system chains like Bridge Hub, Asset Hub, which holds all the assets. For example, you might know about US USDT or USDC. They are actually issued on Asset Hub. Okay, and so why these terminologies are important is because there is some demo that I'm going to show you, so which you can relate to. And speaking about ink contracts, right? You can deploy ink contracts on not just POP network, but any network that has pallet contracts included in their runtime. So yeah, this is the general idea. uh, Relay chain and parachain and testnet relay chains. So like in the hierarchy, right? So when you speak about cross chain transfers, this hierarchy is very important, or it's very easy to get confused, very easy to get confused when you're forming instructions, XCM instructions. So all these POP network, the asset hub, and all other parachains are like the children of your relay chain. In this case, because we are working on testnet, right? So it's Paseo, but in a mainnet, this can be Polkadot and all its parachains like Moonbeam, Hydration, Bifrost. So the next slide is how do you get started when you're coming from Ethereum ecosystem, right? So you have these wallets like MetaMask, but how do what are the wallets that this ecosystem provides? So there are some popular wallets here like Nova Wallet, Sub Wallet, Talisman Wallet. Okay, so these are some community funded wallets, and there is also this thing called Polkadot.js extension. So it's not a typical wallet, but it's just a signer, so that it doesn't have this full-fledged functionality of a wallet. But yeah, these are the wallets you can use to start building on Polkadot. So the first thing, okay, you have a wallet now, but what do you do then? So in the case of Paseo, right? Paseo is like a relay chain testnet of Polkadot. So you need to get this Paseo tokens, okay? And since we are going to work on Ink smart contracts, right? So POP network doesn't have its own native token. It uses dot token. It's the relay chains tokens. So we need to acquire those tokens first. So I have shared all the resources. So if I go to, so there is this hackathon Bible that we have shared with you guys, and I mean, this is the Hackathon Bible is more refined version of this. So there are those links provided of how you can acquire those tokens. Basically, you just this is the Talisman wallet I'm using. So just a minute. Okay. So you can you can make create an account here, copy your address, and it can be any address because the address conversion works behind the scenes. So it isn't like necessary to find a specific network address so that you can get those tokens, but you just paste your uh, address here and you can get the tokens. And the next step is actually uh, bridging those tokens, because as I said, right, Paseo doesn't have its own native token. It uses the token. It uses dot token basically. So you need to go to this interface and just bridge your Paseo from dot to pop network. And the second thing is, okay, pop CLI. So pop CLI is like it bootstraps all your how you can create a new contract, how you can test your contracts, or how you can deploy your contracts, even if it might be a local testnet or it might be a uh, devnet or a testnet. So it can help you to it can make the experience quite seamless. So what are the steps involved when, like, these are pretty generic steps that you all might be familiar if you're like coming from some different ecosystems, maybe Ethereum or maybe Solana. So the contracts which we are going to write, we are going to write in some domain specific language called async. And obviously the next step would be to you first build your contracts so that you can generate the contract, the wasm file, and the metadatas. And one thing that developers often forget is uh, testing their code before launching it to mainnet. So you can test it in your devnet, or you can test your contract on parachain, so it can then be mainnet ready. And finally you can have some nice beautiful interfaces, or you can use the ones provided by the community to interact with your contracts. So I mean, I won't be writing any code here because we just have some few minutes left, but I'm gonna show you a demo, a small demo. So this is one of the contracts which is called XCM. So XCM stands for cross consensus messaging, and XCM are these. Does anybody have question? No, right? Okay, so XCM are these instructions that run on different which can run on the same chain or some different chains. For example, if I want to transfer some tokens to some other person, maybe I would use something like a balances palette to transfer, correct? But you can even do it with something like XCM instructions. So you can form an XCM message, and these instructions will execute on the same chain, and you don't even have to use something like a balances palette. So this is the contract, and you need to be a bit familiar with Rust to get a hang of the syntax here. So the main thing I want to show you here is this message called transfer through XCM. So transfer through XCM is like the call call which you make. And so when I showed you the diagram, right, of the hierarchy between Paseo and the parachains, so this would help in understanding the code here. So maybe we'll start looking at this code from bottom up. And so what we are doing is, here there is a function called XCM execute here, which we are not why we are using execute here, because there are two instructions. One is XCM send and one is XCM execute. You would use send when you have to send an instruction to other chain, but in this case we want to execute this instructions locally. So that is the reason we are using the specific function called XCM execute. And as you can see, XCM is like a version language, so there are different versions like v2, v3, and v4, but currently we are using the v4. And as you can see, I have given the argument as a message here. So now the message part is important. So if you look at the message, right, the message is basically we are crafting an instruction here. So what would it do is it will withdraw the asset, okay, and it will withdraw the asset from the contract, because when you deploy a contract, right, you can think of it as an account which can have a balance. So your contract needs to have a balance, or else your contract wouldn't, the call wouldn't be successful and the contract would be reverted. So what we are doing here is we are withdrawing assets. It's from the contracts account, okay, and if you need to execute instructions on any chain, right, you need to buy some execution time on that chain. This is something isn't free here. In EVM, like, there might be gas, right, but in here it's all about wait. So you need to wait is basically the amount of execution time in picoseconds. So you need to buy some execution time, and you need to pay some fees, right? So what are we specifying here is that we are buying execution time here, okay, and we are paying fees in the asset we are trying to transfer. And for simplicity scenario, we are specifying the wait as unlimited, so there is not like a bound on it. And the next instruction is deposit asset. So deposit asset is basically depositing asset from the, there are also these registers involved, holding registers and stuff, but deposit asset, at the end of the day, what it does is just deposit the assets in the beneficiary's account. So we haven't even used something like a balance transfer logic or something. These are just XCM instructions that are executing on the same chain, and they are transferring those balances. And another thing you need to take care of here is, now we have provided asset everywhere in these instructions, right? So what are these assets here? Okay, so if you look at this line asset, we have specified something like location parent. And why is it location parent? Correct, because as I mentioned, we are deploying our ink smart contracts on a network called pop network, which is a parachain of of Polkadot, ideally Paseo, because it's a test net. So location parent means we are referencing the Paseo chain, Paseo relay chain, and we want to transfer basically those assets. And the value is how much amount of tokens you need to transfer, and the beneficiary is who is going to receive. So network can be anything like, in this case it can be pop, but for this case it isn't necessary to just specify the network, because you are on the same chain. So you just need to specify the receiver. and the thing is, if you think about what's the distinction between locations and junctions, so if you recollect that diagram, that hierarchy that I showed you between Paseo and that relay, Paseo and the parachains, right? So when you say parent, right, you go up the hierarchy, and when I say junctions, you go down the hierarchy. So this is what is going on here, and this is how you get the asset, get the beneficiary, you craft an XCM message, and then you execute the XCM message. If this XCM message was to be executed on some different chain, we would be sending this instructions to a remote chain, correct? So now what we can do is we can try uh, try run, because I have already uploaded this contract here. So this is my account, okay, and basically this is the contracts UI, and this is my account, and we were dealing with something called transfer through XCM, right? And this is on the pop network. So if I go to Polkadot.js apps, okay, I can go here. So there is this test Paseo and parachains, right? So it has the Paseo relay chain and all its associated parachains, but currently I'm concerned about pop network. So I just click on the pop network, switch the endpoint. So we are on Paseo network now, and what we need to do is we need to transfer funds using XCM, okay? So these funds, as I said, would be sent from the contract account, and as you can see up here, I already have 30 Paseo tokens. So now I would just select a receiver. So maybe first let's check some balance. Maybe we can send this to this wallet here, and I just copy the address and I put it as it is 0. Okay, and I paste it here. So this is my beneficiary. Okay, this is the same account which we saw here, correct? And now what is the amount we need to transfer, correct? So our contract currently has 30 tokens. Maybe let's try sending 5. And you can see, right, before even I was entering the amount, we had this something called contract reverted. So basically it's querying the RPC and making sure whether this call would be successful or not. So as I enter the amount 5, it says the call will be successful. Okay, and ref time and proof size are just as you can see, the amount of computational time in picosecond, and which is like what I said about weight and the storage space that you need. So for this contract, since it's a simple contract, we can just go with the defaults provided here, and then we can try calling the contract and see if if we can successfully transfer the funds through XCM. Maybe let's try 10. So I'm calling the contract now, and it would take some time. Oh, do I have an internet? Maybe my internet is not so good. Yeah. So now you can see the wallet that I mentioned earlier. So this is the Talisman wallet, and it's just asking me to approve this request. So I'm gonna approve it, and hopefully this works. So as you can see, the call is successful. But let's check our balance. So as you can see earlier my account did not have any balance, but now it has 10 Paseo tokens in it. So you can see how with just an XCM instructions, I'm just transferring assets within the chain. But this is just the start of it, and there are many possibilities that can come with this, and we want you to build on those possibilities. So some of the examples that can be is like the examples that I can give is maybe try executing some XCM instructions on some remote chain, or you use some different XCM instructions that we have provided in the docs, and I think you would be good to go. So just a minute. Okay, so now we have spoken about ink contracts, right? But maybe you want to deploy Solidity contracts. So currently on West End Asset Hub, there is this palette called Palette Revive, which can help you do that. So if you are keen on deploying your Solidity smart contracts, Palette Revive is the way to go, and we have provided you all the resources that are present in the Hackathon Bible. And to be honest, West End Asset Hub is not the only place where you can deploy. Polkadot has like 100 plus parachains, and some of those parachains have Palette Ethereum and Palette EVM included in the runtime. So these are also some chains that you can target if you're a Solidity dev. Or if you need something more challenging, maybe write your own custom palette, or make your own roll up or something like that. And if you have any questions, you can you can always visit our booth. We are there till the hackathon. And this is the link to the hackathon bible, which would be very helpful for you to develop on Polkadot and its parachains. So you can scan this QR code if you need it. Thank you. Does anybody have any questions?
Okay. All right. Hello, everybody. Really be happy to be presenting at ETHIndia for the second time, and this one is very special because I'm wearing a kurta. And the first guy who hired me, Webhav, who is sitting right there. So a big shout out to him for bringing me in this space 7 years ago. Let's get started. Uh, let's get started to building a full stack Web3 dApp using the graph. Okay. In this, the way it goes is, first of all, I explain what the graph is, then tell you the bounties that we have offered in ETHIndia, which is 7.5k US dollars, and then I'll give a demo as to how to write a smart contract, deploy it, and then build a subgraph on top of it. Okay, if that's cool, let's get started. First of all, it's very important if you're building on the graph that you guys should scan this particular QR code. So I'm just waiting for like 2 minutes if somebody wants to scan this QR code. This is all the developer resources that are required for you to build on the graph. If that's clear, let's start with what is the graph. Okay, why was the graph created? So first of all, if you see blockchains, there are certain limitations to it's a right optimized system, right? The system architecture of blockchains are created in such a way that it's right optimized and it's very, very secure to make sure that it's decentralized. But the problem is that reading is a very big issue. Getting the data from different blockchains to your front end app is a very, very complicated, cumbersome issue. And there are certain solutions, to be honest. There are some 2.5 solutions in which you can use an RPC, or you can use like centralized providers to get the data. But then you will not be your application will not be called a decentralized application, because in a way you're storing the data in a decentralized platform, but the way you're getting it to your front end can be compromised. So you need something like the graph, which will in a decentralized fashion give you the data to the front end. So if you simply say what the graph is a middleware between the smart contract and your front end, so that whatever data you're storing inside your smart contract, that can be pushed to the front end using the graph. Okay. Right now the graph decentralized network has 100 indexers, and if you want to win a bounty, you need to deploy a subgraph on the graph network itself. What is a subgraph? The graph is the protocol, and subgraph is basically your data that you need from the smart contract, right? The graph indexes the blockchain data, but you need to tell that, hey, this is my smart contract address, this is the start block of that particular smart contract address, please just index this particular data for me. So that subgraph is you telling the graph that in a programmatical language that this is what I need, please get this for me. So this is what subgraphs do. Okay. And if you just want to see how the graph works, you can think of like, okay, so the first in a block, this is the data. With the graph, it can be assembled in a way that you get what you need so that you can query it in the best usable format. Okay. How is a subgraph built? Basically, a subgraph is you first of all write a smart contract, and that smart contract has events, and in that events are being emitted and being listed on the subgraph.yaml file, which is the manifestation file. The second thing is the logic file, so that you can convert that event data, raw data, in the data that in the way you want. And the last part is the schema, right? That's where you get the data. That's where you get the queryable data. We'll be going through this when I create a subgraph for you guys, so don't worry. So if you are building a new a subgraph, we have these bounties: $1,000 for winning. If you build the best subgraph, there is judging criteria. We'll be checking it out. You cannot give a vanilla subgraph. You cannot do a code gen subgraph and win a bounty. There are certain criteria in which you will win the bounty, for which we'll be going in details for. So the best price is $1,000, $800, and $700. If you have a smart contract, you should also have a subgraph for sure. Also, the cool thing is we are also giving 10 people, other than these 3 people, we are giving 10 people 10 projects, $250 each if they are building on the subgraph on the graph, and what they build is really cool, and they use subgraph for sure. So this is kind of a pool price from our side. Querying subgraphs. Now there are two things that you can do. If you're writing your smart contract, you need to build your own subgraph. If you're not writing your own smart contract and just analyzing data from different protocols, you can actually just query a particular protocol, and in that the subgraph already exists. So for querying, you just need to go to the Graph Explorer and check what you want to query and get the data. I'll just give a small demo of the same. Let's go to the Graph Explorer and see the first top 10 sales of CryptoPunk NFTs, right? Let's see that. So to do that, I need to go to CryptoPunks, find a CryptoPunk subgraph. I will be using, let's say, okay, let's use this one. Now, let's see the sales of the top 10 subgraphs that has happened, okay? Here, this account, there's punks, and I can just directly go and query the sales USD value of this particular thing, right? Bid and USD. This should be able to give me the data that I need. First 5. So see, this is the CryptoPunks information, and the USD bid and the data is all available in this particular way, right? So if you are creating your own smart contract, you need to build a subgraph. If you are directly querying protocols to get the data, analyze it in your front end, then you can just directly go on the graph.com/explorer and find that particular protocol and just start querying that particular subgraph directly, okay? This is about querying. Let's go towards creating a subgraph now. What if you build your own smart contract? Now you need to actually get the data from the blockchain, creating your own subgraph. This is how a subgraph should be built. There is a blockchain right below, then is your smart contract. Then the middleware between your front end and the smart contract is the subgraph, okay? There are two ways to do it. One way is if you're using Scaffold ETH, you can directly go on, you can directly like install Scaffold ETH and do -e subgraphs, and the subgraph dependencies will come to you. That should be fine. If you don't do that, then you should be using Remix or something like that for writing smart contract code. And for that, there is a different way to get the data. That we will be seeing it now. So what I'll do is, first of all, for the demo, right, I will first of all deploy a smart contract, right? Then we will create a subgraph of that and then query that particular subgraph. If that's cool, let's get started. So I go on Remix to create a ERC20 vanilla subgraph. Let's see. This is the subgraph that this is the smart contract that I have. Let me go and first of all disconnect. Now let's compile this smart contract. It's a ERC20 token smart contract, vanilla, very open Zeppelin, very simple smart contract. Let's deploy this smart contract. Inject. Now deploy. I'm using Arbitrum 1 for deploying my smart contract. It's a mainnet. So I'm spending some dollars for this particular demo, but I hope you have fun. Let's see how it works. So this is my smart contract that I've deployed. You can see over here. The smart contract is deployed. See, we have the smart contract. It's a ERC20 smart contract. Now we will create a subgraph of this, okay? So let's go to create a folder. Let's name it ETHIndia. Go inside ETHIndia, and you need to first of all make sure that you have the graph dependencies. If you don't, then npm install -g global graph CLI. Okay, once you have that, the next thing you need to do is graph init Ethereum subgraph slug ETHIndia. It's an ETHIndia token that we are creating today. Arbitrum 1 is the chain that I'll be deploying it on. The smart contract address is this particular address. Let me make sure I copy the right address that I've just deployed. It will fetch the data from ABI of the like Etherscan here. If you are deploying a smart contract which is not verified, make sure it's verified, and then the smart contract with subgraph code gen should be able to get all the data that's required. Okay. Uh, in the meanwhile, what we'll do is we'll log into the subgraph studio while the subgraph is getting created. So what I did up till now, I made a ERC20 smart contract, and then I deployed it on Arbitrum chain. Once it was deployed, I did graph init in my local repo and directly copied the smart contract address and let that run. While that's been going on, I've logged into the subgraph studio here, and I'll be creating a new subgraph and name it ETHIndia. Create. Okay, cool. So I've created this account in the graph.com/studio, and here is my subgraph. So the subgraph is created now. Let's go and check this subgraph code out a little bit more for you guys to understand. So if I go here, you will see three most important files. The first is the YAML file, YAML file. The YAML file tells the details like, oh, this is the smart contract address, right? These are all the entities that, or basically event entities that needs to be indexed. A transfer, ERC20 domain change, and approval, right? These are the particular events that the smart contract will be tracking for me, right? And then there is GraphQL, like telling them that I need approval data like this. I need the transfer data like this. So let's say I transfer 10 ETHIndia tokens from my wallet to WebHub's wallet, then it will basically be like a event which will be tracked by the subgraph. Okay, this is how this particular thing works. Now what we do is see the mapping file, which is the most important file. So from converting the raw data that comes over here to the finished data that is driven over here, you need to map the logic between the raw data to the way it is, like, to the most purest form, which can be queried with GraphQL, and this is the logic that you write for that. Once all these things are already done by the code gen, right? But if you are wanting to win, you cannot directly just do graph code gen and win a bounty. You need to write a better subgraph. You need to write a denser subgraph with more data. Okay, we'll go in that next, but for now, I hope you understood. There is a YAML file for introduction. There is a schema.graphql for the data that the schema way you want to query, and then there is a mapping file so that the raw data can be mapped to the schema file that you need. Once all these things are done, we can just start deploying the subgraph. But here I'm not looking for all the data. I'm just looking for approval event. Like if I approve somebody to get transfers, I'll just need that data. So let's just cancel everything else. Just approvals. Everything else is not needed, so I'll just delete that. Here as well, just handle approvals. Everything else is not required. Okay, cool. We need to also get rid of this, and yeah, then it should be all good. Alright, the next thing that we need to do is first of all authenticate, right? Authenticate my stuff. Once it's authenticated, the next thing I need to do is code gen and build to make sure that the subgraph that I've created is right. Like it's the code and everything is right. It does the type checking. Okay, that is also fine. Now the next thing that I'll be doing is deploying this particular subgraph. Deploying this subgraph on the graph node so that all my data can start to track. Okay, so I have deployed the subgraph over here, and you can see it live on the studio any moment. See the subgraph is already here. We go on the playgrounds and try to find data. There is no data. Why? Because we have not done any transactions over here, right? Now the next thing I'll do is I'll make a transaction just to show you how this data is being captured by this, subgraph. So let's make a transaction. Let's do an approval. I'll be doing this approval. 100 transfer max, next, approve. See, the data, the I've done a transaction. I'm trying to approve to make a token transfer happen. Up till now, there was no data because I did not do any transactions yet. Now, to get that on-chain smart contract data to my front end, I can directly use subgraph GraphQL API that you can find over here to get the data, and the data would directly come here. I'll do click one button, and the data will be with me. Just see. See, I get the data, right? The on-chain data being posted off-chain for any front-end user to use, directly possible through this. And again, if you want to win a bounty, publish the subgraph on the graph network. Publish the subgraph. See here, I publish the subgraph using some Arbitrum gas fees for any chain. We are live on 40 plus chains, so don't worry on that. But the subgraph is deployed on the graph network, and I deployed the subgraph, and I go on the Graph Explorer to start querying my subgraph. Okay, here I go here, and this is the ETHIndia subgraph that I have created. I can just start querying it. Here you can see, like, the query API. It's a GraphQL API. You can use it in your front end to get all the data that you need. So I created a smart contract, right? That smart contract had events, and to track those events and get that data, I created a subgraph, deployed it on the graph network, and started getting the data with this publication of the subgraph on the graph network, and using this GraphQL API in the front end, right? This is how everything works. I hope you understood and I did justice to the demo. If you're not building a subgraph, you're looking for a more niche use case in which you need not just event data, but also like internal transactions. Let's say I send 10 ETH from my wallet to vasa.eth, and I want to track that. That's not possible with subgraphs. I need to build a substream for that. And if you're building a substream, which is a totally different technology, for that also we have bounties. So just repeating, we have 3 bounties. One is subgraph bounties. First prize 1000, second prize 800, third prize 700. If you build a mediocre subgraph, but you still have a chance, 10 people get $250 each. And if you're building a substream for a more niche use case, these are the prices that we offer. I hope you understood all of it. To get the judging criteria to win a subgraph bounty, this is what you need to scan. This is the most important thing. When you come on Sunday to show us your project, this is what we will be seeing. Okay, so just scan this, and based on the subgraph you create, we will be judging you. Create a better subgraph, use arrays, use enums, create template if you want, maybe use graph client to poll the data. All those things are possible with the demo that I showed you. If there are any questions, I can take it up here. If else, we can just meet outside. I'll be at the booth all day. Thank you. Okay, this is the time to clap.
Hello, can you hear me? Yeah. All right. Cool. All right. Hey everyone. I'm Daniel. I'm probably you've all talked to me at Walrus. I'm here to introduce you to Walrus, show you the overview of what Walrus is, explain why you should use it, and show you how to start using it in your hackathon project today. So for this workshop, I'm going to start with a quick overview of what Walrus is, and then I'm going to show you some quick, easy ways to interact with Walrus. Walrus is pretty simple. We're reading and writing data, so there's not much to it to get started. And then I'm going to go over some products that we have built on top of Walrus already. For example, Walrus Sites, which I'll get into later, and then I'll leave the workshop with some more resources for you guys to use. Okay, so for those of you who don't know, Walrus is a decentralized storage platform. So you can read data, you can write data, you can delete it. And you guys might have been familiar with existing decentralized storage networks, but the way Walrus is built with a lot of lessons. No, they have headphones on. So Walrus is built with a lot of lessons learned from previous decentralized storage networks, and I'm going to show you some of the benefits that Walrus has that's unique to it, Walrus. So replication, when users have to store data on Walrus, the data is replicated 4 to 5 times. So for example, if you want to store 1 gigabyte, the network itself uses 4 to 5 gigabytes worth of storage. And this may seem like a lot, but most prior decentralized stores require full replication. So this means that every node typically has to store a copy of everything that's stored on the network. And we are able to accomplish this because the team at Walrus created a novel 2D encoding algorithm that allows us to shard the data, but still shard it in a way that only needs to be replicated 4 to 5 times. And because we have a constant replication, Walrus is very scalable at the same time. So because adding networks or adding nodes to the network will actually improve the performance of the network. The more nodes there are, the more throughput for reading and writing. So you may think that with 4 to 5x replication, the fact that not every node has a full copy of the data, that there may be resiliency issues, but this isn't the case. Walrus is very resilient. People can still write to the network even if a third of the nodes are down, and you can read the data that you've written to the network even if up to 2/3 of the nodes are down. So you can see that with our new novel encoding algorithm, we are much more cost effective as far as storage goes than other decentralized networks that have to do full replication, but we're also a lot more resilient than the networks that do other methods of sharding the data. In addition to this, Walrus is also very programmable. Walrus uses the SWI blockchain as the coordination layer for Walrus, and I'll go into detail about this later. But what this means is that storage capacity is now tokenized as an asset and is on chain to be used in smart contracts. So this opens up a whole bunch of opportunities there. And in addition to the typical delegated proof of stake mechanisms, we also have novel algorithms that use to attest the nodes. The nodes can constantly challenge each other to make sure the data that is stored on Walrus is secure and accurate. Okay, so what does it mean when I say that SWI, the blockchain, is the coordination layer for Walrus? Typically, other decentralized storage networks, they have to use some sort of custom blockchain or VM to coordinate all of the metadata and global states for the network. But this isn't the case for Walrus. Walrus uses SWI to do all that management for it. And because we use SWI, this allows us to build Walrus with the complete focus on reliably storing and writing the data. And in addition to this, because SWI is very fast and reliable, this also makes Walrus very fast and performant. So in addition to being able to design Walrus with a specific focus and being high performant, using SWI also allows us to program this proof of storage and availability, which means that storage capacity becomes tokenized and is an asset that can be used on chain. So this really opens up a lot of opportunities. Now you can use storage, you can have storage in marketplaces on chain and other aspects. And this also can be used to manage the data ownership as well. And because we use SWI, there is a native utility token on SWI for Walrus, and this Walrus token is used to steer the network economics, incentives, as well as payment for the storage capacity. Okay, and I just wanted to make note that even though Walrus uses SWI as a coordination layer, Walrus is completely chain agnostic. You don't need to be building on SWI. You could build on Ethereum, Solana. You could build on no chain. You could build a completely Web 2 app and still use Walrus to utilize the decentralization and reliability of the data storage. Okay, so that's a little bit of an overview of what Walrus is and why it's different and newer and fresher and better than the other existing data stores. So this is the environment that you'll be looking at with Walrus, and the first way that you can start building with Walrus is through the publishers and aggregators. A publisher allows you to write data to the network, while an aggregator allows you to read that data. And you can integrate into these publishers and use them with either an HTTP API or with a web browser interface. So let's try this out. I encourage you guys to take out your phones and scan this QR code. It will take you to a demo app that we have that allows you to start uploading stuff to Walrus. No CLI or any installment, no installing required. So I'll give you all a moment, and then I'll navigate there myself. Okay, so what we have here is a demo app that we have that allows you to upload blobs. Blobs are the data that is uploaded to Walrus, and this uses a publisher and an aggregator and it integrates this with an HTTP request. So I'm gonna choose a file to upload here. I can do this little avatar. So upload that. And Walrus uses renewable leases, meaning you only pay for the amount of time you want to store your data for. You don't have to pay for 200 years up front, and there's no minimum size or anything like that. So an epoch in Walrus is a day. So let's say I want to make this available for 10 days. So I can hit upload. And we'll see how fast this is. The Wi-Fi isn't the best, but we'll see. Okay, cool. So we can see the image so the image has loaded here, and we can see that this was newly created, and we get two things back. We get the blob ID. This blob ID is what is used to identify this specific content on Walrus, and I'll show you later that this is the blob ID that you'll use to read this data at any other future time. And then we also have the associated SWI object. This is the address of the object that represents ownership of this picture. So whoever owns this object on the SWI blockchain is the owner of this data and can choose to delete it at any time or also renew its lease and extend it further. And we can see here that this is the epoch that this picture will no longer be guaranteed to be saved on Walrus. Okay, cool. And for those of you who want to go further, let me refresh this. If you go to the docs page, under usage, we'll have the docs for the HTTP API, and you can see how to do all the things that this demo app is doing. So here's a list of all of the public aggregators that we allow and all of the public publishers. And then it's as easy as just writing a command like this. You can use curl even, and then just v1 store, and you can specify the number of epochs and then the file you want to upload, or a string in this case, and you get a similar output to what was shown on the demo app. And then it's a similar thing for reading, but it's even easier. You just type in the blob ID here, and then you'll get that file back. And I'll show you this using the CLI in a moment. Okay. So that is one way to interact and start building with Walrus. And the second way to do it is through the client directly. And we have a Walrus CLI that allows you to do this. So I'm going to show you a demo video of this. So these are all the commands that you're able to run on the CLI. You can read, store, get some information, as well as some other things. So this command will tell us the current information for the network at the time. We can see like the current epoch as well as the cost to upload certain sizes of data. And now we can go ahead and store something. So we'll use the walrus store command. We'll specify the number of epochs, and then we'll input a test file, which is, in this case, it's a text file. So right now the data is being split up and distributed to all of the different nodes in the network. Okay, cool. So after a successful store, you'll get the blob ID as well as the sweet object ID that we saw in the demo app. So I just copied this blob ID so that way I can go ahead and read this data. At this point, anyone on the network can read this data. So walrus, read, and then the blob ID. And then at this point, the data will be retrieved and displayed on the terminal here. So we can see that this was the contents in this text file. Okay. Okay, and like I said earlier, Walrus uses SWE as a coordination layer, which means you are able to build on Walrus using SWE smart contracts. So this is a third way. It's out of scope for this hackathon, so I'm not going to be showing you exactly how to do that, but if you're interested, you can always come by and ask us and we can show you later. Okay, so that's the basics on how to use Walrus like in a hackathon project. There's not much to it. It is just reading and writing, and we wanted to make it as simple as possible, so there's not much instruction for it either. But I wanted to go over this product that we have on Walrus called Walrus Sites. Walrus Sites allows users to deploy decentralized websites onto Walrus. So you can go ahead and deploy and upload the static image files to Walrus, and then we're hosting web portals that allow you to display these sites. And just note that the web portal aspect is decentralized, and anyone else can host their own portal. So you're not relying on the Walrus protocol to display the sites. And we've actually seen that in previous hackathons. We've seen other people host their own portals. So at this point, I want to show you an example of Walrus sites. So we have this NFT minting site called Flatland. You can find it at flatland.walrus.site. I can provide the link for this later as well. But so what this is, it allows you to mint a new NFT, and this NFT has a specific shape and color to it. But the cool thing is that each NFT has its own Walrus site associated with it. So this really you can kind of read it down here, but so every NFT has a unique site, and I can show you this here. So I'll mint a new one. Okay, so it just loaded. It just replaced the old one I had here. So we can view the site. So this website is completely specific and unique to the NFT itself. If you go to the NFT on the Explorer, you'll see that it has this purple color and this amount of sides on the shape here. So this is an example of how you can use Walrus sites in a decentralized manner. Every NFT can be viewed by its own website, and also to note that the owner of this NFT is the owner of this website. So at any point, if the owner of the NFT wanted to update the site, they could do this because they own the actual NFT. Okay. Yeah, so if you guys wanted, I didn't go over the details of how Walrus was built or the algorithm that we used to split up the data, But if you're interested in learning more, you can scan the QR code on the left, and this will take you to the Walrus white paper. And then if you want to look at all the links all the websites I showed right now, and access to the docs and everything, we have the starter pack on the right that you can scan. Okay. Thank you. I want to thank you all for listening and being interested in Walrus and potentially building on Walrus. And I'd love to take any questions you have now. And if you have any other questions that you'd want to take personally, I will be at the Walrus booth in the other room. So yeah, thank you. That's okay.
Mic check. Hello. Hello everyone. Not audible? Yeah. Hello everyone. They are saying go ahead, no? No issues. No, they have done it. Hello everyone. This is Om from Huddle 01. So before starting of this workshop, just want to go in a depth about what is Huddle 01 and what this people-powered communication means. So yeah, a little bit about me. I'm one of the founding engineers at Huddle 01, and yeah, I started off working at Huddle 01 when I was in second year of my college, and since then we have scaled the system from like we started off as a hackathon project, and just like ETHIndia, we were part of HackFS, and then we gradually matured and become a company, and here we are, giving talk on the same hackathon. So yeah, that is a little bit about me, and you can follow me on Twitter. So a little bit about Huddle 01 is Huddle 01 is building the world's first deepin for RTC, and there's a reason why deepin for RTC is colored like this. So I can dissect these two words, deepin and RTC. So what is deepin is so in a full form, deepin means decentralized private infrastructure, right? Something like that. So it's complicated for a reason in Web3. So what's public infrastructure, or what's infrastructure in sense? So when you talk or when you do anything on the internet, everything goes or everything is routed to a public infrastructure, and that infrastructure is mostly cloud, right? Everything is through cloud. And then deepin says, hey, we will decentralize this private infrastructure, and why do we do it? That will I explain you in a later sense. But Huddle 01 is really building a real estate to do all kinds of real-time communication. When I say real-time communication, it's basically talking to one another. So before deep diving into this network, I just want to go on why we build deepin infrastructure. So this is one of the examples of egress cost. So what is egress? Egress is basically meaning the data cost which every cloud provider, every server, every person who basically manages these public infrastructure charges you to basically take the data in and send the data out. And so that is basically your egress. So in this so there was a tussle with AWS and other companies like Cloudflare, which were up and coming, and they did some research, and that they found that the cost which AWS buys data for, which is also very might be surprising for you, is this amount, which is 0.08, and then they sell it for like $6, which is about a markup of 7,000%. Now it might be possible that hey, AWS sets up all this private infrastructure, they have to buy all these lands and stuff, but still in the 21st century you have to pay 7,000 markup just to talk to one another is pretty absurd. And that is why Huddle 01 is that business to basically build a deepin for RTC. How can we be better and be cheaper? And why we do this is because one of our CTO always says that communication is the building block for literally everything. Like globalization changed the whole world, and it was communication between human and human, and that is what drove the world closer. And so basically, impact of human to human communication is now converting to a impact of human to AI communication, and that is where this workshop is all about. How can you build AI agents with RTC? So before going into a little bit depth, I want to show you what is an AI agent, because that's the whole workshop about, how to build an AI agent. So when you talk about AI agent, you must be finding on the internet that AI agent is someone you talk to, but AI agent can be something much more than that, not just about conversation but about action. And I think that is where this AI agent thing will pan out, where let's say you order something from Zomato knows what kind of things you like, what is the weather, and how to do the payment. If you know about Stripe recently actually released an agent API, which is totally phenomenal. So the world is moving towards that kind of agent which does action for you, and that the action that it does is basically on your command, that what you speak and what you say is basically a communication, right? So agent to agent communication is not necessarily speech, it can also be a data transfer, and that is what real time communication is all about. That hey, a agent is talking in real time with another agent. It's not necessarily speech, it can be literally anything. So this is what this image shows, that there's an agent in in the center, and then it has all this memory, it has all these tools, it has all this social ability, it has, let's say, persona, which it can take on and do some task, and that is what an AI agent is all about. So how do we build these communication between agents, and how do we build in a sense where you're not getting charged so much, and we are also getting all the things about that Hurdle 01 has built over the years, and that is the DRTC network, which I want to just go over a little. So DRTC network is nothing but a real estate which you basically get when you want to do any real-time communication. When I say real estate, I don't mean land, I mean real estate in your laptop, in real estate in your phone, real estate on literally any place which can or which is able to send all those packets or all those RTC things. That is what DRTC is all about, and that is this flywheel is showing that what Hurdle 01 has done, or what I have done and my team has done for 4 years, is building this network which is essentially a real estate for all these communication needs. I will not go in much detail. There's a white paper which you can read, which I will show, like if I have the, no, I don't have, but I will share the QR which you can actually read about, and it's also on our website, which goes much in detail about how the DRTC network works. But about the workshop, it's about AI agents. So I just want to go in a little bit depth about how these agents work. So in a very higher level system design, this is the how the agents will work and how these agents will utilize the DRTC network. So DRTC network is a real estate, as I said, which enables real-time communication. Any user can basically communicate with other user using DRTC network, and in that session, an agent can be a part of the same conversation. It can listen, it can do tasks, any client can basically call and say to an agent, or the agent API. As I said, Stripe has one, and soon or later every company will have those kinds of APIs, can basically do some action, and that agent will always be connected to a large language model. I don't need to go into depth about what large language model is, everyone knows about it. uh, so yeah, this is going to be the system design, and this is what you will also be thinking when building any hackathon project using our SDKs. And when I say LLM, it's basically it's but obvious that anything AI will be done on Python. So previously we didn't have our Python SDK. We are in ETHIndia we are releasing our Python SDK, and we were actually fortunate enough to actually get this name AI01, which is actually a very cool name. And I'm pretty surprised that no one actually thought of it. And yeah, so yeah, pretty much I'm pretty excited to announce this in ETHIndia. And there's a demo which I also want to show. Uh, so a lot of people talk about AI agents, but not a lot of people show them working on your systems or live. So I actually want you to show that to you, that hey, these things work. It can talk to you. I just hope that you can hear its voice. By the way, you can also join this link. This is internal Hurdle 01 link where you can join and do the meetings, but don't overuse it. Did I miss a word? Yeah, sorry. Two laptops. So yeah, this is your natural meeting which you join, and it will be pretty cool if I could have shown you the terminal on my laptop, but I can't. But it can talk, so that's what we want. Just give me a minute to wake it up. Uh, 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 uh. I just hope nothing breaks. And as always, something broke. So I think the internet is not fine over here. Anyways, you can actually go and check it out in our repo, which is so it's the first time Hurdle 01 is open sourcing its SDKs. So with the Python SDKs, we envision that we will be accepting contributions. We want to make a community around the AI wave that we are happening, and I can show you the SDK. Yeah. So this is the SDK, and this is pretty much which we will be using to hack around in our ETHIndia track, and to basically see what I wanted to show you, which is not working. You can use this example chatbot, and when you clone this, you can go to this page, and you can basically talk to this AI agent, and it's pretty cool. I seriously want you guys to basically see this example before you start hacking in ETHIndia. And about ETHIndia, we have a $5,000 bounty, and you can scan this tag, and you can know all about the different tracks that we have. As I see a lot of people seeing this, so I just go and explain a little bit about it. So we are dividing the bounty into three parts, which is the AI, the Unity, and the JS. So the AI will have $25,000 bounty, so that is about 50% of the bounty, and 2,500 yeah, $2,500 bounty, which is about half the 50% of the total bounty. And I wanted to do something different with this hackathon, so I just restricted the AI projects to just these 5 tracks. I don't want any other track. I just want these 5 tracks in AI, and these 5 tracks can be covered in just one day. You can basically code it in let's say 7th December, and they are pretty holistic. They cover a lot of things like live trading, live instrument tuner, and also open source, because I see a lot of people in ETHIndia are open source lovers. If you like to basically contribute into our basically agent, you can clone the repo, go on Gemini, Claude, Grok, Anthropic, and all these LLM providers, and you can make providers of it with compliant to our agent API. And I actually am very excited about this one, if someone can pull this off. And the rest 4 are pretty easy. You can go through it. And then we have the Unity and the JS SDKs. I've kept these 2 tracks pretty lenient, and the JS SDK will have these proximity games and open innovation and procedural video visualization and Fall Guy clone. So this is basically the ideas. So Unity and JS is pretty open, but AI I want these only 5 tracks. So that's the ETHIndia hackathon. So yeah, our team will be around if you have any doubts. We will be more than happy to accommodate them. And yeah, that's pretty much it for my presentation. Any questions? Yeah, thank you.
Can I start, or are we ready to go?
I'm wondering why I can't. Can you speak?
Yes. Oh, hello.
Yeah,
Yes.
it's working.
This
We
works?
can go.
Okay.
We can start, and there's the timer.
Okay. Perfect. Thank you very much. Okay, let's get this going. Hello, Angelo Shelley. I'm going to talk about Akave. I'm going to keep it very brief because I want to dive into like the tech right away. So I'm going to talk about like around the interfaces and specifically on how we do our data structure. So we'll get that like going right away. As you can see on the screen right now, I'm going to look at it from a zoning perspective on what we do today. So how our hot storage layer works and how you can access it, so I can dive directly into the docs and explain how you use that today and how you can build on Akave. So when you look at from the top to the bottom on the left, you see that we have our SDK and our CLI ready to, to interact with our interact with our storage layer. And you will be talking to one of our zones that we set up for the hackathon. So it's a public open zone. Keep that in mind when you're talking to it. Data is not encrypted, so make sure that, or you encrypt it yourself, or you're storing data that can be accessed publicly. Now, we do permissioning based on the blockchain itself, so based on your wallet address that will be segregated. You'll see that in a little bit when I go through the documentation. Then on specifically on how you interact, we'll go into the docs and get that going. Let me see here. So these are the documentation of Akave. It's on docs.akave.ai. We have multiple ways of interacting with our storage system. So as you can see here, like our SDK CLI will give you optionality for the fully blockchain integrated use of Akave. We have our streaming API and our normal API. Mainly focused would be on the blockchain integrated one, which would give you all the functionality that you would be needed for this hackathon challenge. So here on the blockchain integrated one, let me quickly go over it, how you install it and use it. I'll talk about the SDK CLI on how that works and what your need is to make it work, and then we'll go into the JS wrapper and then explain like how you can programmably use Akave. So right now, what you need is basically just go at least like version 122, which you can install. We added like a really easy to use Mac OS example and a Ubuntu OS example, which is very very step by step, very easy to go. Don't forget to always add your path here because that will give you like some issues later. And then it's really easy. Our GitHub repo is publicly, so you can download it right from there and quickly build it. Takes like around 30 seconds to 1 minute to build, depending on your internet connection. So that should be fairly quick. One thing is like, important here is that if you want to have it like readily available throughout your entire operating system, move it to like a location where it can be executed by every user. Goes for Ubuntu, Mac OS, or other operating systems. And then you're basically ready to go, right? So what you need to do here is make sure that you go to our faucet where you can claim some tokens. Very easy. What you do here is, this is not my computer, but I'll show you. Let's see. Oh. Here we go. So what you do is you add Akave to MetaMask. It's all already pre-configured and pre-filled in, so you can just quickly add it to your MetaMask. Always like a little disclaimer, make sure to make like a new wallet address because else it will be tied to your other EVM compatible accounts, which you don't want. And then you can claim like 10 Akave right away from our test network, and you can get started. Now, once you claim those tokens and you have like your own wallet address on chain, you will need your private key that you need to export out of your MetaMask, and then you can get started on using that on our infrastructure. Now, on the blockchain side, and this is also very important, let me open that. To give you some information around, let me check here. Open this data flow for a second. As you can see here, this is the data flow on the Akave side, where you can see that data that comes in through any of our easy to use like interfaces, it will get broken down into chunks. And then what we basically do is we calculate like a Merkle tree hash out of that and derive the root CID, so you can access it that way directly. and all that information gets stored on our infrastructure on the blockchain. Now, the reason why I bring this up is that all this interaction from storing data to the chunking to uploading, accessing, creating a bucket, all that information gets stored on chain. So when you, like from the second you start interacting with our network, you will see when you fill in your wallet address here, you will definitely see all those interactions like happen on this level when we get into like the blockchain commands to interact with our network. Around here, very important, keep in mind, if you want to connect on our network, this is what you need. This is the, oh, it's not working, oh, here we go. The connect.akava.ai, make sure to use port 5500. You will see here when you're working on using our CLI, you'll see that all these commands, we call them IPC commands, are used at the end here to use the private key. Let me see if I can show that here. Here we go. That you need to import your private key. Now, if you don't want to see that every time in your execution of your commands, you can go down here and you see like we put in an approach to secure a private key. So you store it once, you cache it, and then you can just use it in your command like as a cached variable and then use it that way. And then basically it's very simple moving forward. It's like simple on like creating a bucket, which is a virtual representation of your data, where you can then like view and list all the different buckets that you created, which you can segregate data in if you want to. If you want to segregate it by user, you'll have to create multiple wallet addresses, and then per wallet address you create multiple buckets. And then when you go further, it's the same as basically any object store or any storage system is, where you can interact with files, you can upload, download, and then list them, get some file info going. So this is our basic approach to our CLI. And the reason why I explain this, so you have some context in the part where I'm going to go in next, which is the part that most people or most builders use to deploy anything on a Kave. So here, we call it a Kave link. Really easy to use. The repo is open. The only thing you need is Docker. What you do basically is you spin up a small Docker container. What it does is you import your private key. It spins up an API that then talks to the SDK that will talk to the decentralized Kave network. And it's as easy as pulling the Docker image. The same way you go to the faucet where you get your tokens, and then export your private key. You put in your private key here once in the Docker container, and you spin it up based on the IP address you put in here. The same here for like connecting to the node. Same information you need here. And once that's done, you can basically interact with it with any code that you're used to. We put in some examples here to get like some information around what's happening, and we put like the equivalence of like a curl command so you can see how easy it is to interact. So if you want to use Java, which a lot of people use to interact with it, you can talk to the API and get that information going. It's the same around listing buckets, creating a bucket, viewing the details, and also on the file operations, very simple approach as well here, where you can go through on uploading and fetching data. And here are some examples on how to get the data back, download the files, and interact with it. Now, I think the main one where you want to see on the blockchain side is then once you have all this done, you can go into our Explorer. Let me see if there was anybody working on it right now. Let's see. Right now people are taking some funds out of the faucet, so nothing to show yet. But definitely once you look at like what's happening there on your specific wallet address and you interacted with it, you'll see all the different operations opening up there. And that was my demo on Akave. Now, I don't know how to proceed, but can we take questions, or is there anybody who has some questions? Oh, it's a silent. Yeah. Yeah, people can ask me questions if they want to, but I don't have any. Let me see. Yeah, mostly covered the ones that are needed. Just make sure that you keep in mind that connecting to the network is connected at Kave.ai on port 5500. And when you spin up the Docker image, if you want to make the API publicly available to others to interact with your application that you're building or downloading software, make sure to host it somewhere publicly so people can access it, because if you run it on your notebook alone, that would be impossible to do from that perspective. Okay. I can take some questions if there are any, and besides that, that concludes the workshop for me. Thank you very much. We're good.